Welcome back. In the last video, we talked about geometric mean and showed how one's in the denominator, one's in the numerator, and they're the same number that go in those two places, the geometric mean of two other numbers. Okay, so let's see how we apply that in a right triangle. There's two different ways we're going to do it. The first one is called the right triangle altitude theorem. Okay, and it says the altitude from a right angle in a right triangle is the geometric mean of the divided parts of the hypotenuse. Okay, so let's kind of unpack that. I know when I'm looking at a geometric mean, my denominator of one fraction, or one ratio, is going to be exactly the same as the numerator of the other one. The geometric mean in my right triangle altitude theorem is the altitude from the right angle. The altitude from the right angle is the geometric mean. Okay, so just to kind of make myself like a little formula, I'm going to say the altitude is the geometric mean. So that altitude is going to go in the same place. And remember, the altitude from the right angle. So when I look at this whole triangle, here is what makes it the right angle, right? The right angle in the corner. Okay, that's the right angle of the right triangle. And remember, your altitude leaves from a corner and hits the opposite side at a right angle. So that's why I have another right angle right there. Okay, because your altitude hits a side at a 90-degree angle. So we're leaving the right angle, hitting the opposite side at another 90-degree angle. Okay, so this altitude here is my geometric mean. And what are the other two numbers? Okay, it's the geometric mean of the divided parts of the hypotenuse. Okay, so it's going to be like a part 1 and a part 2 of the hypotenuse. And remember, your hypotenuse is going to be the longest side that's across from the right angle in the corner. It's going to be the one that the altitude touches and divides it into two pieces. So you're going to have part 1 and part 2. Okay? So my example here says find the altitude z inside the right triangle. So I'm trying to find this altitude in the right triangle. So I'm going to set up this proportion. The altitude is the one that repeats here and here. Okay? So my altitude is the one that is the geometric mean. That's the same. Okay? So that in this case is going to be the altitude z. And the two numbers here are the two parts, oops, I forgot to put part 2, that the hypotenuse is divided into. It's divided into an 8 and a 25. Okay, notice those parts don't have to be the same, 8 and 25, because this isn't a median, right? A median would divide it exactly into two equal pieces. This is an altitude. Okay, so now this I can solve, right? I can just cross multiply. So I'm going to do z times z, which we said is z squared, is going to equal 8 times 25, which is 8 times 25. Let me grab my calculator. 8, oops, clear out what was in there. 8 times 25 is 200. Okay, so now all I have to do is get rid of that square, which we said is not dividing by 2. It's taking the square root, because square roots and squares cancel each other out to leave me with just z. If I square root on this side, I have to also square root on this side. So come on back, calculator. Now that 200 is already in there, so I could clear this out and I could retype the 200, but since it's already in the calculator, I could just hit, remember that the square root symbol that has the little 2 on it. We don't want the one with the 3, because that's something we're going to do later in the year called cube rooting, and we don't want to do that. Okay, so I am going to click on the square root, and notice it does it automatically. And we said in geometry we're always going to we're going to round to 3 places. So 14 point and then go 3 places. 1, 4, 2. So that's where I want to round to. But then I look after the 2 to see if I have to go up or down. Since it's a 1, I don't go up. I'm just going to stay 14.142. is going to be my answer. 14.142 is Z, the altitude of this triangle. Okay? So that's the first one where you're working with the altitude of the triangle. The second one we're going to look at is called the right triangle leg theorem. So let's look at the right triangle leg theorem. The leg of the right triangle is the geometric mean of the hypotenuse and the adjacent part of the hypotenuse when it's intersected by the altitude drawn from the right angle. So again, there's a lot going on there. So we know we're working with, we saw that word geometric mean. So I know that means that geometric mean is going to be here and here. The leg of the right triangle is the geometric mean. The leg is the geometric mean. So leg and leg. Now every right triangle, the two sides that are not the hypotenuse, the two sides that come out of that right angle in the corner are both legs. Okay? They're both legs. So you have to know, am I working with the X here or am I working with the Y? Notice it is going to ask me to find both of them. Okay? What goes in these other two corners? Let's see. The geometric mean of the hypotenuse and the adjacent part of the hypotenuse when it's intersected by the altitude. So remember, we already have the altitude drawn in our picture. We found that. It's 14.142. Okay? So the hypotenuse is one piece and the other one is the adjacent part of the hypotenuse. So I'm going to do HYP for hypotenuse, and then I'm going to do ADJ for the adjacent part of the hypotenuse as my other two sides. Okay, so that's kind of like my formula. So I've got two formulas so far, and they're not official formulas. You won't find them on an actual like formula chart anywhere. They're just kind of how I set it up to look at it. Okay, all right, so if I want to find, let's start with X. If I want to find the leg X, this leg right here. Okay, I know I'm going to find X, and I know that X is the geometric, that leg is the geometric mean. So I know it's going to go in the denominator of one fraction and the numerator of the other fraction. So my leg is X, my leg is X. Okay, and then in my other two pieces are going to be the hypotenuse and the adjacent part of the hypotenuse. So look across from the right angle, the main right angle, is my hypotenuse. How long is that hypotenuse? They didn't tell me, but I know segment addition says that this hypotenuse, I have to go 8, and then I have to go another 25. So 8 plus 25 is going to give me that whole hypotenuse. 8 plus 25 is 33. Okay, so now I know the hypotenuse is 33. It also says the adjacent part of the hypotenuse. So remember, my hypotenuse is divided into two parts. If I'm trying to find this leg, the adjacent part, the 8 and the 25, which one, the 8 or the 25, is next to this leg? Well, if I were to highlight this leg and then not pick up my pen and try to highlight the adjacent part, that adjacent part would be 8. And that I can cross multiply and solve. So x times x gives me x squared equals 33 times 8. And 33 times 8, I already have a 33 in there, so I'm just going to hit times 8, is 264. And to get rid of the square, we're going to square root both sides, and we only need the positive answer. My square and my square root cancel, so I just have an x. I only square root one time. The square root of 264 is already in there, but just in case I'm worried about it, I can clear it out and do 264, and then again I want to hit the x squared button, or the square root button, and then I'm going to round to 3 places. So if I cover this up, 3 places after the decimal, 248, and then look after the 8 and see it's a 0, so I don't have to round it up. It's just 16.248. 16.248 is my value for x. Okay? All right, and then I still want to find y. Y is also a leg. It's my other leg. I'm going to do it in blue here. Okay, so if I want to find y, again, y is a leg, so it is the geometric mean, which means it's going to go in the bottom of one fraction and the top of the other fraction. Y is the geometric mean between the hypotenuse and the adjacent side. Well, my hypotenuse hasn't changed. It's still 33. But the adjacent side, when I highlight here, my adjacent side is now the 25. Okay, the 25 is adjacent to the y, the 8 is adjacent to the x. And this, I can cross multiply and solve. So when I cross multiply it, I'm going to get y times y, which is y squared, equals 33 times 25. 33 times 25, let's see, clear that out. 33, there's a glare on there, times 25 gives me 825. And then, to get rid of the square, I'm going to square root, because square roots and squares cancel out. So all I have left on the left-hand side, oops, Mr. Garcia is sending out an email, y equals the square root of 825. So I've already got the 825 in there, but if I want, I could clear it out and retype it, 825, and then square root. And again, we want to go 3 places, but round correctly. So 3 places after the decimal is 7.22. When I look after the second 2, I have an 8. So I do want to round up this time. So I'm going to go 723. So 28.723, because I need to round up that last 2. 28.723. All right, so my right triangle altitude theorem, my altitude is the geometric mean of the 2 parts of the hypotenuse, and my right triangle leg theorem, my legs are the geometric mean of the whole hypotenuse and the adjacent part of the hypotenuse. Okay, so hopefully those 2 makeshift formulas will help you using geometric mean in right triangles. Okay, the next video is going to have some examples, just doing this kind of a few times over and over again to help you get comfortable using the formulas. Okay, thank you so much for watching.